Hello, everybody. Welcome to What Do You Believe? Welcome, Francesca. We're happy that you're here and you're going to ask questions and tell us what you think. And welcome, Dr. Nagy.
Hi.
Dr. Nagy Eskandar is a medical doctor and he's the fellow of the Royal College of Surgeons in England, and he practiced surgery for 25 years. That's a long time. And I think you're talking about something now that you like because you know you're doing surgery for 25 years. You've worked with a lot of biology.
Of
So we've
course.
talked last episode about the complication of a lot of things, from a simple cell to like all. We're obviously going to keep going into biology to figure out more
Exactly.
complications.
Exactly. What we're going to see on the screen now is the five senses that we all enjoy. And by these five senses, we recognize the world and we enjoy life, really. It is touch, it's hearing, it's smell, it is taste, and it is vision. And all of these five senses are great, and we thank God for all of them. But they are so complicated, and it cannot arrive really by chance and time and laws of nature. It has to be designed. And let us take them one by one, really, to see how complicated they are. So let us start with the eye. And the eye is very complicated. I'm just showing you on the screen the outside structure of the eye, the globe of the eye. And there are 6 muscles controlling the movements of the eye. And we need to keep moving to adjust and to see. So this is really how the eye is moving, with these 4 muscles called recti, and then 2 oblique muscles, one at the top and one at the bottom, to move this eyeball, to different directions. And I think that cannot just happen by chance. Natural selection cannot just select one muscle at one particular point and then select another one and the third one and the fourth one and decided to have another muscle on the top. Because as we said, the natural selection selects from what's available. It doesn't create muscle. It doesn't create the eye globe. It doesn't create the lens. It doesn't create any of that at all. Let us see a little video now explaining the function of the eye.
The human eye is a marvel of design, much like a video camera, but far more advanced and versatile. Like some cameras, the eye is autofocusing. To do this, man-made cameras have to move the whole lens, but our eye changes the shape of its lens. Like a camera, the eye bends incoming light and creates an image inside the eye. But unlike cameras, the eye also sharpens the image along the edges. Similar to some cameras, the eye automatically adjusts to brightness, so we can see day or night. In fact, in dark conditions, the eye increases its sensitivity to light up to 100,000 times. Eyes are much more sophisticated than cameras. They convert the light image into electrochemical signals, which are sent immediately to a brain that processes the images and makes necessary adjustments. Many other aspects of the eye surpass anything humans can design. Eyes are self-cleaning, self-lubricating, and self-repairing. Even more marvelous, eyes are built automatically in the womb. No camera can repair or build itself. Evidence of design appears in all types of animals. Each eye seems specially designed for its environment, whether an eagle in flight or a fish in the sea. For example, owls have a special surface in the back of their eye which reflects light back through the retina. It helps them to see better in the dark. Flies have another design, a compound eye, which helps them to detect the slightest motion. Such diverse yet exquisitely designed eyes show the handiwork of our Lord.
So this little video about the eye explains how difficult or how complicated the eye is. And you compare that to a camera. The camera doesn't happen by chance and time and laws of nature. It has to have an engineer and a manufacturer and get the right components to put them together. And you have to adjust them manually or automatically. But the eye adjusted, when I look at David here at a distance, My eye adjusts to that level, and then when I look to my computer, it adjusts in instances immediately to see the screen in front of me. All of that happens all the time. And the other thing as well is the lubrication of the eye, the tears, and they are very important because it keeps the eye wet and viable. So there is a gland here called lacrimal gland, which secretes this film of water, and that goes and cleans the eye from bacteria and other things. And there is a little duct here, and it goes draining the tear into the nose and then into the system. This doesn't happen by chance and time and laws of nature. This little duct here, if it is blocked, will be having tear all the time. Can you imagine if our life just tear all the time because of this secretion of this lacrimal gland wetting my eye and this duct is blocked? We obviously surgically can treat that. Some people have dry eye and we have to give them artificial tears in order to keep the eye wet. Do you think all of that happens by chance and time and laws of nature? You need massive amount of faith to believe that. And then the picture, when it is received on the retina, and the retina is very complicated. There are something called rods and cones, which can differentiate the sharpness of the picture and the colors, the different colors. And all of that has to go through the optic nerve, and the optic nerve crosses in a place called chiasma, and that goes to the center in the brain to interpret the picture. And then it's linked to the memory. So when I see David after, I haven't seen him for a couple of years, and I see him, oh, this is David, I know him. I saw Francesca because I have seen her a couple of days ago. Yeah, I realize who is she. So all of that happens in fraction of a second. Do you expect natural selection to do that? Natural selection is not a creative power. And mutation is bringing us backwards, not creating anything positive in our body. So when there is a mutation, there is cancer and other diseases. So really, we have to think of this wonder of creation and look at the Creator and acknowledge Him and praise Him.
So what's the possibility of having an organism, a cell, whatever we want to call it, that started to learn its needs and develop slowly, or just a learning process to be able to adapt to environment or whatever, to be able to get to that point?
Right.
If we want to think about it that way, is that possible?
Right. You have to have information in the nucleus for this cell to adapt to the circumstances they found themselves in. So you have to start with information in that cell. And
so if I start with a cell of a skin, I can't develop all that to a cell in the eye and the mouth and the hair, like.
No, you can't. There is something called ectoderm, mesoderm, and endoderm. That means the zygote, the sperm, and the ova, when the ova is fertilized, they form the zygote. The cells in that zygote are able to differentiate into three main lines: ectoderm, mesoderm, and endoderm. Ectoderm forms the nervous system and the skin. The mesoderm forms other organs like the digestive system. And endoderm forms another. So you have to have the information to form all of these structures.
And does that happen naturally by chance, or?
It cannot be by chance, because you have information to produce ectoderm, producing the nervous system and the skin, for example. So the information has to be embedded in the nucleus. And the information doesn't come from matter, because information comes from information, according to the information theory by Werner Goethe. So the operational science tells us the information does not come from matter, it comes from intelligence.
Because I think that's one of the only ways we can actually watch development in front of our eyes. As a baby grows and come to the world, you don't know anything, you're starting to learn, and you develop to get to where you are today.
Yeah.
So that happens, and it's observational, we can see it.
Yes.
Can we apply the same ideas, the same structure to life over millions of years?
Right. This baby is developing because he has all the information necessary for him or her to develop. They are built in. That's why he is or she is developing. If you don't have any information to form an arm, the arm will never form. So you have to have the information to have the body. And this little baby can learn because there is ability, there are genes responsible for speaking, and he has a vocal cord, and he has a larynx. So he has all the components of speech. That's why he or she are able to speak. And that applies to all other organs. So they are maturing and developing because the structure at the beginning have all the necessary information to develop all of that. But if you start from nothing, and if you start with different components of amino acids and expect them to come together to form all this complicated body, I think this is imaginations beyond the imagination, really. It cannot happen that way. But as I said, people who are trying to explain life without God said we don't want to keep God in our knowledge, as the Bible describes in Romans chapter 1. We refuse God, we refuse a creator, but we have life, so we have to explain it. So they look at the chemical reactions. Yeah, we have great knowledge now understanding the chemical reactions in the body, but understanding the chemical reaction does not create them. Because they are created, we discover them. Like the gravity, we don't create gravity, but we discover the law of gravity. So in order to discover law and chemical reactions and all of that, we need an organizer, we need a creator. So you can do the operational science because there is a God. That's really how the logic can complete the picture for us.
Well, we'll take a short break. Let's take a few minutes to think about our bodies and what's going on in there, and we'll be right back. Don't go anywhere.
Thank you for tuning in. If you have any questions or comments, or if you'd like a copy of this episode, please call 714-709-4300 or email us at info@alkarmatv.com. You can also visit our website at www.alkarmatv.com. Also, you can write to P.O. Box 3610, Seal Beach, California 90740.
Welcome back to What Do You Believe? And we're talking about biology and our body, and we want to keep going.
Exactly, yeah. So we have discussed the eye and the vision and how we can see and all of that. Now we move to another thing, which is hearing. And hearing is really a very complicated sort of mechanism in our body. And we hear because there are waves coming, and there is air between us. And these waves hit the air in different vibrations, and it comes to the ear, and we'll see how it's transmitted from one stage to another. We have external ear, we have internal ear with 3 little bones, which magnify the sound, and this is transmitted through a special membrane into something called the cochlea, and in the cochlea there is fluid, and this fluid will affect fibers moving, and these fibers have cilia, like hairs, and these hairs really are the cause of our hearing. Let us watch this little video, which really explain a very complicated function in our body, which is hearing. And we thank God for hearing. We can enjoy talking to each other, understanding each other, listening to music, and it's just wonderful to have all these 5 senses working in our body properly. We have discussed vision, and now let us see hearing, or hearing, yeah. So we'll see this little video together.
Many of us take for granted a very extraordinary organ, our ears. To understand the ear, we need to understand what sound is. The speakers you are listening to right now are vibrating, flexing in and out, causing a wave of pressure through the air. The frequency of these waves, or the speed at which the sound creating surface moves back and forth, affects the pitch of the sound. The level of air pressure in each wave is directly related to how loud the sound is. The outer part of our ear catches these waves. It faces forward and has a specially designed structure of curves helping us to determine direction of sound and emphasize frequencies needed for human speech. Now that the sound waves are caught, they travel through the ear canal and strike against our eardrum, a thin membrane about 10 millimeters wide. Now that we receive the sound, the middle ear transfers this energy. The smallest bones in your body, the malleus, incus, and stapes, start in motion. The malleus is attached to the eardrum, and as the sound passes along, the force is amplified by leverage until it arrives at the stapes, which acts like a piston, creating waves through the fluid of the inner ear. The most significant increase in force comes from a system of hydraulic amplification. The face of the stapes has a surface area of 3.2 square millimeters, while the eardrum has a surface of 55 square millimeters. Using this, along with a leverage through the malleus and incus, the final pressure is 22 times greater than when the sound first arrived. Now, we arrived at the most complicated part of the hearing, the cochlea. In reality, it is coiled up, but it is easy to understand straightened out. The stapes is causing pressure waves to travel through this structure. Along the inside wall is about 20 to 30,000 reed-like fibers. As the waves move along, it encounters fibers with the correct resonant frequency and energy is released. These fibers are not actually what give the signal to us that we heard something. There is a special structure containing hair cells next to these fibers. When the fibers resonate, they cause the hair cells to move, which then sends an electrical impulse to the cochlear nerve and on to the brain. Certain pitches of sound will resonate in specific locations, and louder sounds will cause more hair cells to move. Our brain interprets all this raw data, making it possible to enjoy a beautiful song or a conversation with a loved one. Just to think that all this is happening in your head right now at full speed. And not just one, but two of these sophisticated instruments are helping you to have the amazing sense of hearing. This is just one of the many systems found in the human body that go far beyond our humble human understanding.
I hope you enjoyed watching that film, actually. It's really amazing that these waves that comes and transmitted by air, if there is no air, we wouldn't hear each other, by the way. So living on Earth, that's not by chance. The presence of air is not by chance. It is designed. And for a design, you have a designer. And the Bible explains He is God Almighty. So these waves transmitted in the air and then comes to the outer ear, and then on the drum, it will be hitting the drum with certain energy, and this is magnified through small little bones, and this goes to another membrane and goes to the cochlea, and the cochlea has many, many fibers, 20 to 30,000 of them, and these fibers, as they transmit this energy, affect some cilia, and this cilia is transmitting that to the auditory nerve, and that goes to the brain to understand what we are listening to, music or sound or speech or whatever. And we can listen to different things at the same time. You can listen to music and listen to somebody talking to you, and you differentiate that. This is very complicated. That cannot happen by chance and time and laws of nature. Really, you need faith of some sort. I can't describe it really. To believe that all of this can come by chance and time and laws of nature, having two ears, two auditory nerves, going to a center in the brain, and the brain interprets all of that properly for you to enjoy music and speech. That cannot happen by chance and time and laws of nature. Of course, we'll keep going. So let us have another one, which is taste. And taste is very, very important in our life, really. We can taste food, we can smell food, and the smell is another thing which is related to taste. And I have a friend, actually, who had an operation, and she lost taste. And she really struggled when we have meal together. She doesn't taste anything. Can you imagine? You are not tasting the food you are eating. It's all bland, it's all the same. But taste is very, very important function in our body and gives us so much pleasure and enjoyment. Again, that cannot happen by chance and time and laws of nature. Let us watch this video together.
The tongue is the main organ of taste. Its surface is covered with tiny protuberances called papillae. The circumvallate papillae, across the back of the tongue, are the largest. They also have the most taste receptors. Taste receptors are cells lodged in the folds of the papillae in groups of 50 to 100. The ends of the gustatory cells have cilia at their tips, which protrude from the folds of the papilla. When one of these cilia comes into contact with a substance that has a flavor, the gustatory cell generates a neural message. The neural message is emitted by gustatory cells on the tongue and in the rest of the oral cavity, are sent to the brainstem, and then to the cerebral cortex, which generates the conscious perception of taste. However, taste is a limited sense, since the papillae distinguish only 4 basic flavors: sweet, salty, sour, and bitter.
So from this video, we see that the taste buds at the back of our tongue, they can taste only 4 basic elements, and the combination of all of these give us the different taste that we enjoy. And that has to go, it's a chemical reaction when these taste buds face this or interact with the food we are eating, for example. It can differentiate these 4 basic tastes and transmit them through nerve to our brain to interpret what we are eating and what type of food we are eating and what flavor we are enjoying. Again, my question is, can you explain that by time, chance, and laws of nature? Really, it cannot. This is so complicated. I'm just going through these 5 senses just to show you how complicated our body. If I talk about the circulatory system, about respiration, about the skin, about the digestive system, about any system in our body, about the immune system that we have, it's essential for life. If we discuss all of that, we have to come to the conclusion that there must be a creator that cannot come from chance and time and laws of nature. We can go for another organ again to see how the smell is really an important one in our body and our function.
Like all the other systems of the human body, the sense of smell is also an extremely complex design. Now let's examine more closely the various parts of the system. The nasal cavity that detects smell is just beneath the eyes and is lined with a sticky mucus fluid. This mucous membrane measures just 6/100th of a millimeter thick. Specialized olfactory nerve cells are another part of the smelling system. The basic task of these cells is to take messages from smell molecules and take them to the olfactory bulbs. A smell cell is formed by 3 main parts: the cell's body in the middle, and then on one end, tiny hairs called cilia, and on the other, nerve extensions called axons. At this point, astonishing things happen at the axons on the other end of the smell cell. The axons, whose number ranges between 10 and 100, work together in order to transport the signal in the cell to the olfactory bulb inside the brain. They do this by forming a bundle in order to reach the olfactory bulb, and as a group pass through a porous, paper-thin piece of bone called the cribriform plate. It would be no exaggeration to call the special design of the cribriform plate a miracle. This bone has pores in it which allow the passage of the olfactory neurons. Had the bone not been designed in just this way, it would have been impossible for the nerves to connect to each other, and so would have made smelling utterly impossible, even if all the other pieces of the system were right in place. By virtue of this perfect planning behind all the details of our smell system, communication in the smell cells goes off without any hitches. The olfactory bulb is another important part of the olfactory or smell system. The olfactory bulb lies on the front side of the brain, on top of the nasal cavity, concealed upon the brain case. There are 2 olfactory lobes in the brain, just as the nose has 2 nasal cavities. Each of these lobes is about as big as a pea. The olfactory lobes work like a newsroom at a TV station or newspaper. All the signals coming in from the olfactory receptors first gather in this center. Millions of pieces of information are reorganized here. Later, they are sent to the related spots in the brain through smell nerves in order to be reassessed.
The olfactory membrane is a thick yellow-brown structure, about 1 inch square, located in the upper part of each nasal cavity. It consists of about 100 million smell receptor cells, which are surrounded by supporting cells. The smell receptor cells have an olfactory vesicle bearing cilia, which project into the mucus that covers the smell membrane. Chemicals in the air react with the cilia and stimulate the receptor cells. The smell information is passed by the receptor cell axons, which leave the membrane as the first cranial nerve, and which relay with mitral cell axons to the olfactory cortex. The supporting sustenacular cells contain a pigment that colors the membrane yellow. The membrane also contains Bowman's glands, which secrete mucus. Their function is to keep the membrane moist so that chemicals can dissolve and stimulate the cilia.
If you can't smell, you probably can't taste very well either. They are closely related functions. Receptor cells for taste and smell are located in the mouth and nose, respectively. As the receptor cells are stimulated, they send impulses from these organs to the brain's smelling and tasting centers in the cortices. For taste, impulses stimulated by the chemical compounds in food are sent to the gustatory cortex. For smells, impulses stimulated by chemical compounds in odors are sent to the olfactory cortex. As new compounds stimulate the receptors, the brain forms an odor memory bank so that it can recall the odors the next time they are present.
So this film showed us how complicated the sense of smell is. And this interaction between the vapors of the smell into the nasal cavity and the mucous membrane, and that's transmitted through nerve fibers. And these nerve fibers has to come to a part of the skull, which is called cribriform membrane. That means a membrane which is, there are holes in it to allow these nerves to come inside. I think that's amazing structure.
Well, thank you. We'll come right back to five senses in the next episode. Dr. Marasamal said one time, every day you have a choice, to feel or to be, to feel good or to be good. So just think about what do you believe. Thank you for watching.